Let's take this simple question into consideration. Find internal rate of return for the following project. A lump sum amount of 2 million to be paid immediately and 1.5 million at the end of 1 year. So this becomes our expense. An annual payment of 0.1 million to be paid at the beginning of each year for 4 years. So this becomes an annuity, and at the beginning of each year they are saying, so that means it is going to be our annuity due. Then we'll have an income of 1 million per annum that can be expected at the end of each quarter for 10 years, starting immediately after 4 years. So basically we have two lines of our expenses and one line of our income. So first we'll try to make present value of our expense equation. So first of all, I will do the calculations in millions. So I'll get 2 plus 1.5 V plus 0.1 A due 4. So we have 2 million, 1.5 million at the end of 1 year. So V, and an annuity of 0.5 million at the beginning. So we'll have due of each year for 4 years. Then we'll go for present value of our income. So we have 1 million income that can be expected at the end of each quarter for 10 years. So at the end, so we have arrears, so we get A 10 payable 4 times, and it is starting immediately after 4 years. So we have 4 years of construction period or something like that, and our income starts after that. So we'll have to discount this for 4 years. So always remember, they will mention it. See, our income was for 10 years. The language is very clear. So income was for 10 years. They did not say that it will go up till 10 years. So if they say that it is going up till 10 years, so total number of years from 0 to 10 will be our payment, or you can say it will start from 4 and it will go till 10. So we'll have only 6 years of payment. But because they say the income is for 10 years, that means that the payments are for 10 years and it will be starting after 4 years. So through total we are going to have 14 years of time period. So we need to find the interest rate or internal rate of return, where present value of our expenses becomes equal to present value of our income. So for that, what we have is a way of solving using our calculators. Now in our calculators there is a mode called table that we are going to use for this particular case. In that particular case, what we are going to do is we are going to use a function. Basically we will find an fx and it will ask us to put out a function, and it will put different values of x in that particular function to actually give us different answers of our fx. So using that we will be able to find our interest rate or IRR. So first we'll make our function. Now in this particular case, I is the unknown value. Okay, I is here, we have I here, we have I here, and we have I here. So it will be impossible for us to make such an equation such that we have only one value of I. Therefore we are resorting to this particular method. So we have fx, and where x is our variable, in this particular case I is our variable, so we can keep I is equals to x. But instead of keeping I equal to x, I prefer keeping 1 plus I is equals to x. Now why am I keeping 1 plus I is equals to x? Because you will find V a lot of times in these equations. So v is nothing but 1 plus I raised to minus 1. So it becomes much easier to write x instead of always writing 1 plus x every single place. So it's much easier to just make the equation using 1 plus I as x rather than using I as x. It is going to save you time and it is going to save you space, because there is a limited amount of space in your calculator, limited amount of digits that you can input in your calculator. So it will not take a very long equation. So we have to be precise about it. So for that, now let's make our equation. I will take present value of expense minus present value of income. It does not really matter, you can take it other way around as well. So we'll get 2 plus 1.5. Now instead of v is nothing but 1 plus I raised to minus 1. So I can write this is nothing but divided by x. X is nothing but 1 plus I. So divided by x. And I'll have plus 0.1. Now we will have our annuity equation. For annuity, we'll have 1 minus v raised to 4. It's annuity in due, so denominator will have d. So d is nothing but I upon 1 plus I. I can write this as denominator as our x as 1 plus I, and I would be nothing but x minus 1. So I can write this as x minus 1. So in the denominator I can write it as x minus 1 divided by x. Next I have minus income. Income I can just write it as 1 minus v raised to 10. Now okay, my mistake, instead of v we want x, so we'll have x raised to minus 4. Here we'll have x raised to minus 10, and denominator we'll have I4. So our I4 is nothing but 4 into 1 plus I raised to 1 by 4 minus 1. Now I can write that in the denominator. I can put 1 plus I as my x. So therefore we'll get 4 into x raised to, instead of writing 1 divided by 4, I can write 0.25 minus 1. So this becomes our equation that we are going to put in our calculators. I found this particular app which is very similar to our calculators that we use, that is FX82 ES Plus, and I can demonstrate everything that we are going to do in this particular case. So basically we have a calculator like this. We have to go to the mode where we can use this particular table value. So you will have to press mode, that is on top right of your calculator, and mode, and as you press it will show you different options. This is not exactly the FX82, so that is why this has a lot many options, but in your calculator you will see 3 options, and we have to use table, that is third option. So just press 3. So as you press mode 3, you will go into the table mode and you will see fx is equals to. So it is asking you to give your function, write down your function. Now one single problem in my function, I forgot to put this v raised to 4. Okay, so we'll do that. We'll have divided by x raised to 4. So instead of when I write v raised to 4, it should be 1 plus I raised to minus 4. So instead of writing x raised to minus 4, I prefer writing divided by x raised to 4. You can just write into x raised to minus 4. It will be the same thing. Now we'll input our equation here in the calculator. We get, now when we put x, how do we put this particular value x? Now if you see above your bracket value, you will see an x in red. In this particular case we have violet. In your calculator it will be in red. So just see above del there is a bracket, and above bracket you will see an x. So to access that value, you can use alpha button that is on your top left. Whenever you press alpha, and then you can access any of those red values, or in this case purple values. So I'll press x. See, when I press the bracket I get x in our equation. So alpha x. So I get 2 plus 1.5 divided by x plus 0.1 into, I'll put fraction 1 minus again alpha and x raised to minus 4. Then in the denominator we'll have bracket alpha x minus 1 divided by alpha x, and then minus 1 minus alpha x raised to minus 10, and we'll have 4 into alpha x raised to 0.25 minus 1 bracket close, and lastly divided by alpha x raised to 4. So this becomes our whole equation. Now you don't have to show this particular equation in your paper. This is just, I wrote this to explain you how we are going to input it in our calculator. Now we have put the function. When you press equal to, it will ask you for start. When you press equal to, it will ask you for a start, because what it is going to do is it is going to give you an table where give you x versus fx values. So for different values of x, it will tabulate different values of fx. For that, it needs the range of x. Where do we start the value and where do we end the value? Now the limitation of our calculator is that it can only give 20 values. So if it can only give 20 values, what we prefer is to take such values such that our start and end is going to be from 0% to 20%. So if I take 0% to 20% as my interest rate, my 1 plus I becomes 1 to 1.2. So I will keep start as 1 and then press equal to, end I'll press 1, usually it shows 5, then just press 1.2 and equal to, then it will ask you for steps. Now our steps should be in such a way that the difference between our limits should always be less than or equal to 20. So if you want, this is our end 1.2, this is our start 1. So what you can do is you can say end minus start upon 20. So you will find that you get 0.01 as your steps. So we get steps as 0.01. I have put steps as 0.01 and then just press equal to, and it will show you the tables. Now in this particular app, it's slightly different. It is showing you fx and gx. We have not put anything as gx, so forget about that. In your calculator, it will show you x and fx values. Now what we want is, we need to check where does we get our fx equal to 0. because our fx is nothing but present value of expense minus present value of income. We want that value of rate of interest where these two are equal. Now unfortunately, you will very rarely or almost never find directly value as 0. So we want such values between which 0 lies. So whenever you see in this particular case at 1.12 and 1.13, you can see the value is going from negative to positive. So value will go either from negative to positive or positive to negative. That just implies we have crossed 0. So that means 0 is going to lie between 12 and 13%. So now we know the 0 is between 12 and 13%, but we need to be more precise. Whenever we are finding IRR, we should give at least 2 decimal points. That will be like 12 point whatever percent we are going to get. So that 2 decimal points I am talking about. And whenever we are comparing multiple projects, we should take at least 3 decimal points as our answer. So basically we cannot just settle with 12%. So we have to go more precise. For that, just press AC. When you press AC, it will take you back to your function screen and your function will be same. It will show you the same function. Now what we have to do is we have to go more in depth. So I'll just press equal to. It will ask me for start. Now we know our value is between 1.12 and 1.13. So we'll keep that as our start and that as our end. So 1.12 becomes our start and end becomes 1.13. Now for our steps, we would want such that we get multiple values between them. You can divide it by 20 and find, but I prefer to just take just divide it by 10. So I will get steps 0.01. Instead of that, I want 0.001. So our next steps becomes 0.001. When I press equal to, you will find the values now are fx range from 1.12 to 1.13 and our value between 1.122 and 1.123 is going from negative to positive. Now we know that the value of 0 is between them. So what we are going to do is we'll take that as our next step and we will go further. So now next our limits are 1.122 and 1.123. So press AC again. We'll be back with our equation. Press equal to and it will ask you for steps. So our now initial step should be 1.122 and our end should be 1.123. Now our step should be one more step ahead. So we'll take 0.0001. Now when you press equal to, you will find now the values, the 0 value is actually between 1.1227 and 1.1228. Now this is good enough. We have 12.27 or 12.28 as our answer. 2 decimal points, good enough for this particular case. Now we need to know whether to write our answer as 27 or 28. For that, just look at their fx values. Now which is more closer to 0? Now for 27 it is 10.608 something and somehow something is not right there, forget that. And in the 12.28 value you will see that we have 2 decimal points and then 227 and so on. So that seems much closer. So I can just say that my interest rate I or our IRR, internal rate of return, is equals to 0.28%. So for your internal rate of return, your answer should look like, first you will have to make equation of present value of expenses, present value of income, then just write present value of expenses will be equal to present value of income at IRR, and then you can directly write IRR is equals to 12.28. You don't have to show any of the calculations that we did or write any of the equations that we wrote. So this becomes your internal rate of return. This is how we'll find IRR. So our internal rate of return is nothing but the rate of return at which we are earning per annum. So we are getting our money back. Now if our NPV, net present value, was positive, that means we were earning profit when we took it at market rate. That just says that we are earning more than the market rate. Now we said NPV is positive. NPV is nothing but present value of income minus present value of expenses at market rate. I'll just write it as MR, market rate. So when will this particular value will be equal, or you can say net present value will be equal to 0? If we increase the rate of interest or the market rate, we will get that the income will be discounted more than the expenses. Now I will explain why. Now almost every single time, rather logically, it should always occur that let's say we have n year of our project, so we'll have most of our expenses done at the beginning of our time period, from 0 to 3 years or from 0 to 4 years. Whenever we are making a project, we will invest first a lot of money. Starting may you might have to buy the land, or you might have to invest for material and labor and machinery and so many different things. So basically your investment at the beginning would be a lot, and your income will start after some time, usually after your expenses are over. So your income will always start later than your most of your expenses. And if I sell after n years, what happens is I get a lump sum amount or big income value at the end. Now whenever we are discounting, we can see that this value will be discounted for n years. These values will be discounted much more than these values. So that means our expenses will be discounted less than our income. So naturally, if I increase the rate of interest, the present value of our income will be affected more or will decrease more than the present value of our expenses, because we know present value is nothing but future value divided by 1 plus I raised to n. So these are our future values at whatever time we are going to get our income, or whatever time we are going to have our expenses, and we are trying to find value at time 0. So you can easily see, as I increase the value of I, present value will go down. Now because of this particular n being higher in our income than our expenses, the present value of our income will go much faster down than the present value of our expenses. So if I increase the rate of interest and I had profit, I was going to get profit, then for a higher rate of interest, I might get my present value of income equal to present value of my expenses. That higher rate of interest is nothing but our IRR, internal rate of return. So that internal rate of return has to be more than the market rate. Logically, you should earn more than whatever others are giving you interest at whatever rate, because if not, then you will just give them that money and you don't have any you don't have to work, you don't have to take risk in investing in your own project. So therefore your internal rate of return should be more than the market rate. Now what happens is, let's say I am doing this particular project, whatever question that we were talking about. Now in this particular project, as you can see that we had few income projections and few expenses projections. Now these are all projections. Today I cannot tell you what income I am going to get, let's say 5 years from now. But we can project, we can assume, or we can find out what might be the value then. But that still does not change that there might be the difference with what I expected and what I actually got. Now simply we might have, while I was having construction, there might be some earthquake which I could not anticipate, so I had to pay more. There might be flood for which my material got washed away, I had to pay more. So there might be some unforeseeable circumstances for which I might have to pay more. And maybe I was expecting rent and there were few months when I did not get rent because there was nobody who was renting my place, so I might lose income, so my projections might fail. So therefore what we want is my internal rate of return to be more than the market rate and significantly higher. So let's say if my market rate was 10%, so my interest rate or IRR should be much higher than the market rate. If it is just, let's say, 10.5%, why should I take the risk of my project going wrong, or there might be some other unforeseeable circumstances that might come with which we might not be able to make this mark. So therefore my internal rate of return should be higher than market rate, but it should be significantly higher. Now how much higher? That percentage we call it as risk rate, risk rate of interest or risk rate. Now let's say that whatever risk I am going to take, I say that my risk rate is 3%. That means whatever someone else is offering, that is our market rate, that is 10%. My internal rate of return should be at least 3% more than the market rate. So in this particular case, I should earn at least 13%. If I am not earning 13% or higher, then it is not worth taking the risk in this particular case. So even if my rate of return is higher than the market rate, I will not take this risk, because my risk rate or my calculated risk is that I should at least earn 3% or more than the market rate. So this is just a question. In questions they might give you a risk rate. This is how we use our risk rate. Whatever the market rate is, we just add a risk rate to it, and my internal rate of return should be at least that much higher than the market rate. So these are the few concepts. First of all, how do we find internal rate of return? Then if interest rates at which we are calculating, or the market rate at which we are calculating, goes higher, then first of all our net present value, so if I goes higher, our net present value will go lower, because the income will be affected more, or income will be discounted more than the expenses. So these are the two things that we should remember, and other than that we just talked about risk rate. So risk rate is that rate of interest at which we cannot take risk, or that is the rate of interest of us taking the risk. Now the third point that we look for is our payback period, how fast we can get our money back. Now payback period is nothing but the point in time when we receive the value of our investment back. That means, let's say I took a loan, or I gave a loan of 10,000 rupees at time 0, and I am receiving every year 1,000 rupees. Now how fast can I get my money back? Assume it is going on forever. Now we can easily say that I gave 10,000 rupees, I am receiving every year 1,000 rupees. So I will receive my money back in 10 years. That becomes my payback period. So simple si baat hai. 1000 into 10, we will get 10,000. So in 10 years we will receive our money back. That becomes our payback period. But the problem with payback period is this is not very accurate. It is not telling us the value that we are getting back. It is not considering the time value. Now imagine if I gave this 10,000 rupees to someone who was going to give me interest at 5% rate of 5%, then what will be the value, or how fast can I get my money back? How fast can I earn? So every year he is giving me 5% more than 10,000. So discounting such value, we can find our discounted payback period, or DPP. This is our third value. Now let's try to find, if we introduce interest rate, what do we get? So first of all, present value of our expenses is 10,000, and present value of our income will be 1000 A10, or in this particular case let's take N. How fast can we get our money back? So basically I can say that 10,000 is equals to 1000 AN, or instead of AN I can write 1 minus V raised to N upon I. I am assuming I as 5%. So we get 10 is equals to 1 minus 1.05 by 0.05, or if we rearrange, we'll get 1.05 raised to minus n is equals to 0.5, or our n is going to be, how do we solve this we need to find the power value. We'll take log on both sides. So we'll get n is equals to minus of log of, instead of log I prefer writing ln, just because wherever we have log it is always log to the base n. In this particular case you could take any base log, but I just want you to use ln more than you use log, or I should say don't use the log value. So we get n is equals to minus of ln 0.5 by ln 1.05. So just use our calculator. Now going back to our normal mode, calculator mode, rather than the stable mode, just press mode and 1. So you'll go back to your calculator mode. So we'll have ln 0.5 divided by ln 1.05, we get minus 14.2066 because we had negative value, so this will be positive. So basically, if we can earn at 5% rate of interest, then it will take us 14.2066 years, or actually to get our money back. So you can see that this particular 10 years value is not very accurate. Actually, we are not going to receive the money at this particular point of time, exactly 14.2066. We are not going to earn money at this particular time. We will earn money either at 14th year or 15th year, end of 14th year, end of 15th year. Now we can easily tell that at time 14 we will not be receiving all our money back. The present value will not be equal to 10,000. So we'll say our DPP, or our discounted payback period, is nothing but 15. So we'll say our DPP is equals to 15 years. So basically, if you say that you are getting your money back in 10 years or 10 installments, and just by looking at that you say 12 installments are good enough, you will be losing money in that particular transaction, because we know at 5% rate of interest your money will be returned at 15 years. So this particular term is called as DPP, or discount payback period. Tells you when are we going to get our value, either the present value or the time value of our investment back. Now let's solve this particular sum. It is basically the same sum. Instead of finding interest rate or internal rate of return, in this particular case I just made it to find DPP, discounted payback period. So we need to find discounted payback period for the following project at market rate of 9% per annum. So I can write down my present value of expenses. My present value of expenses become same 2 plus 1.5 V plus 0.1 A due 4. Present value of income will be equal to 1 into A10 payable 4 times a year V raised to 4. Now whenever we want to find DPP, the point of time where we get our investment back, that means our present value of our expense will be just less than or equal to present value of our income, or you can say that point of time when our income will take over. Now we'll say when our present value of income is slightly higher or greater or equal to our present value of expenses, that time will be called as DPP. So when present value of income is equals to present value of expenses, we'll say that N is DPP. Now in this particular case, that just means we don't know the value of N. So I cannot just assume my N to be 10 in this particular case. Now simple si baat hai, in as you can see, I don't have to change this 4. Now why don't I have to change this 4? Because I did not have my income started at this particular time. So definitely my time or my DPP will be anywhere between 4 to 14, because this is going for 10 years total. I will have 14 years. So my time when my income takes over my expenses is going to be anywhere between 4 and 14. So my present value of income equation should look like AN payable 4 times V raised to 4, N being our DPP. Present value of expense will be same. Now what we can do is we can first find this present value of expenses directly, because we can put all those values. Interest rate is given as 9% per annum. So we'll use that to find expenses. Now I would suggest find this A due 4 separately. If you remember, we can use our tables to find this A due 4. That will be nothing but A4 I by D. So in our actual formula table, page number 61, physical page number 61, PDF page number 67, we have 9% rate. Now in this we will take our A4. I'll just so A4 is 3.2397 and I by D, we'll take I as 9%, D is this 0.0825. So just take 0.09 divided by 0.082569. So we are getting 3.531264,760. So this will be equal to 3.5312647. Then I have to just add 2 plus, we'll have 1.5 V is nothing but divided by 1.09, and the answer or present value of our expenses will be equal to 6.907411,549. Now for calculation, I have always said you should use at least 6 decimal points. For writing, I write as many as I can in that particular time, but 6 decimal points would be good enough. So present value of expenses. Now we'll say our present value of income will be equal to present value of our expenses. So we'll get, or I can just write it here, will be equal to 6.907411. I'll just make some space. Now in this particular case we have only one n, so you can actually find that you'll get 1 minus v raised to 4. V raised to 4 would be 9%. You'll have 1.09 raised to minus 4. No, sorry, not v raised to 4, minus n payable 4 times. You can find I4 from our tables. or you can just write 4 into 1.09 raised to 0.25 minus 1 into v raised to 4, or you can into 1.09 raised to minus 4 will be equal to 6.90411, whatever. So now what you can do is you can use your tables or this particular calculator to directly find n, or you can use the tables as we used in IRR. I'll just explain. In this particular case you don't need to use that tables to find n, but I will just show you how we can do it if we have multiple values of n that we cannot combine to make one. We'll go back to tables, so mode tables, we'll make our equation where now our variable x will be nothing but n. So the equation so this becomes our equation. I have taken everything on one side. I have taken x instead of n. For x we again used alpha and this particular x. This becomes our fx. I'll press equal to, it will ask me for start. Now my start, we know that our n will definitely be between 4 and 14, because up till 4 we had no income and for 10 more years we got income. So our DPP is going to be between 4 and 14. So my start will be 4, end will be 14, and I will take my steps as 1. I can take 0.5, but I just always like to keep it as whole numbers or 1 values, so it just becomes easier. Now we'll check for when we get our transition from negative to positive. We are not getting anything from negative to positive. That just means I made some mistake. Yes, okay, I got my mistake. My A due 4 was whatever value I got from my okay, I did not multiply by 0.1. So I'll go back, I'll just calculate A due 4 using our normal way. 1 minus 1.09 raised to minus 4 by d is nothing but I upon 1 plus I, so 0.09 divided by 1.09. We are getting this 3.53129 and so on into 0.1, no, my mistake, not here, into 0.1 plus 2 plus 1.5 divided by 1.09. So basically our present value is not 6 point, present value of our expense is not 6 point whatever, it is 3.729276. We'll use this value to go back to our tables. We'll have to make our equation again. So this becomes our equation. Start value will be 4, end value will be 14, step will be 1, and now you can see between 7 and 8 we are getting a 0 from negative to positive. So that means our DPP is between 7 and 8. So we'll take that value and we'll try to find a little bit more accurate value. Now because my payments were per quarter, you can see that my payments, my income was every quarter. So I would like to know at which particular payment my present value of income became greater than the present value of my expense. So for that I want my answer to be accurate in quarters. So I know that my answer is between 7 years and 8 years. Now which quarter am I talking about of that particular 8th year? So again I will press AC. I got my equation back, equal to, and now my start will be 7 and my end will be 8, and because I just want the answer to be accurate in quarters, what I will do is my step will be 0.25, that's it, 1 quarter. Okay, so we are getting that in our first quarter payment the value became from negative to positive. Now if you remember, we took, so it is pretty clear that the transition is at this particular point. We took present value of income minus present value of expense. So basically at time 7 my expense was more than my income, therefore my FX was negative, and at time 7.25 or our first quarterly payment the income became higher than the expenses. That means this is the time when we got our money back. So our DPP is going to be 7.25 years, or you can say that is nothing but 7 years 3 months. Okay, this becomes our DPP or discounted payback period. This is the time when we got our money back. Now what happens if I increase my rate of interest? Here I had 9% rate of interest. What if I slightly increase my rate of interest? What happens to my DPP? Again, this is a conceptual question. I'll just explain. For any such DPP, any such value, any such project, if I increase the rate of interest, what happens to my discounted payback period? Again, I'll try to explain with the same concept that we used in IRR. So if let's say I have n years of project, most of my expenses will be at the beginning of my project and my income will be spread out, or most probably it will be lower value of income, so income will be spread out over a longer period at a later time. And if I have a large value of income, that will usually be at the end. So if my rate of interest is higher, then what happens is, let's say if my DPP was at this particular point of time, at this point of time my present value of income was slightly higher than my present value of expenses. Now simply, if I increase the rate of interest, we know that because income being at higher number of years will be discounted more. If it will be discounted more, then my present value of expenses will be discounted, but it will be will go down, but it will go down less, and present value of my income will go down more. So basically, the point of time where my present value of income becomes equal to present value of expenses will start becoming higher and higher and higher. So as interest rate goes up, my DPP goes up as well. So we have two relations. If I increase the rate of interest, my net present value goes down and my DPP, discounted payback period, goes up. That just means the time that will require me to get my investment back will become more.